Okay, so there are many ways by which we can divide covalent compounds into multiple groups. One of the most of them, the most common of them being, we can divide them into polar covalent compounds or non-polar covalent compounds. Now, what is a polar covalent compound? Simply put, a covalent polar compound has slightly negative or slightly positive charges. Now, let's take a step back. Let's take a look at a molecule that we're all familiar with, water, H2O. So, this is a water molecule. What happens is that this oxygen atom, this oxygen atom, which is um, this oxygen atom, which is quite, this is one, this oxygen atom is quite thirsty for electrons. So what it does is it snatches the hydrogen electrons a little bit towards itself. Now, because electrons are negatively charged, there is a slightly negative charge on oxygen, and whereas there is a slightly positive charge on the other two hydrogens. Now, what this implies is that water molecules, that two water molecules, just because, let me draw the water molecule. Yeah. So the other charge is slightly positive, slightly negative, slightly positive, slightly negative. You get the point. So what happens is that this positive hydrogen would attract this negative oxygen. So this intramolecular bond is is a very strong bond. In contrast, non-polar molecules don't have slight charges on them. A very common example would be methane. Because hydrogen and carbon are the electron density, the electron density between them is it's quite even. So there are no dipoles formed between them. Hence, there is no so basically because the electrons are distributed evenly, there are no positive charges. Now, does that mean that methane molecules won't be attracted to other methane molecules? No, not at all. So what happens is um, let me draw a methane molecule. What happens is that because there may be some instances where electrons are deviated from their, or not even deviated. There's a slight probability the electron cloud, let's say that this is the normal electron cloud of the methane molecule. There's a slight probability that the electron cloud could shift to like this. So this hydrogen would get a slightly positive charge, whereas this whole other area would get a slightly negative charge. This slightly positive charge would then induce a slightly negative charge on this hydrogen, which in turn will change the electron density between this molecule, and these two molecules will interact. These type of forces are called van der Waals forces, and these generally tend to be way weaker than the bonds that exist between polar bonds, which can either be hydrogen bonds. This one, by the way, is a hydrogen bond. This one is a hydrogen bond, or they can also be dipole bond. So, so the main takeaway from by this is that non-polar molecules are attracted to each other by relatively weak forces, whereas polar molecules are attracted to each other by relatively strong forces. So, polar molecules tend to have a higher melting point, whereas non-polar molecules tend to have a lower melting point. This is no rocket science. If you have a stronger bond, you obviously need to to give it more heat, to give it more enthalpy, to give it more energy to break the bond because the bond is stronger. Same goes for boiling point. Boiling point in polar molecules tend to be higher, whereas in non-polar molecules they tend to be lower. Okay, solubility. This is a very interesting concept. Now, what happens is because I told you that polar molecules have hydrogen chloride is another polar molecule. Hydrogen chloride is another molecule. Now, what happens is that polar molecules, because they have polarities or charges on them, they can be dissolved in only polar solvents because this hydrogen will attract oxygen and therefore the water will be attracted to hydrogen chloride and hence it will dissolve. But hydrogen chloride won't dissolve in a non-polar solvent. Let's take benzene, for example. Benzene or ethane, whatever. Uh, let's take benzene. The structure of benzene is not important right now, but let's just say benzene is a non-polar solvent. Hydrogen chloride will not dissolve in benzene. Why? Because benzene doesn't have attractive sites for hydrogen chloride. Likewise, methane will not dissolve in water, but it will dissolve in benzene. Why is that? Because van der Waals forces can exist between benzene and methane so that they can dissolve. So the rule should be like dissolves like. Polar will dissolve polar, non-polar will dissolve non-polar. Now, electrical conductance. Polar molecules can conduct electricity when they're dissolved in water or they're in solution form. Why? Because when this HCl dissolves in water, it segregates into hydrogen ion and chloride ion. Now, as we know, what is electrical current? Current is the movement of ions or electrons from one place to another. And hence, when you give a potential difference, if this is a water solution of hydrogen chloride and and you give a potential difference. This is plus 6 volts, this is 0 volts. If you give a potential difference between the two ends, the ions will move. Hence, a current can be generated. So, polar molecules can conduct electricity provided that they are dissolved. However, non-polar molecules they don't conduct electricity. Density. Now, polar molecules generally tend to have higher density than non-polar molecules. Why is that? Well, it's simple because of the bonds are stronger, they are more compact. And as we know, density equals mass upon volume. A compact thing has less volume, so the density increases. So polar molecules have higher density, whereas non-polar molecules have relatively lesser density. So an interesting example to conclude the lecture would be this. If you take a container, if you take a container and you fill it with a non-polar compound, let's just say um, octane. Let's say octane. Oh, there we go. Octane. Then you start to fill water in it. What will happen? Well, these two can't mix because like dissolves like, and water is polar. Water is polar, whereas octane is non-polar. So these can't mix. But what will happen is because water is denser, it will displace octane. It will displace octane, and octane will come, and octane will rise to the top. So what will happen is water will be at the bottom, whereas octane will be at the top. Yeah. Okay. Hope you understood everything in this lecture. I'll meet you in the